So on example number 9, we're supposed to find the product. And so the pattern here would be one of these three patterns: the sum pattern, difference pattern, or sum and difference pattern. And after looking at it, we can see that this here is a difference pattern. So I'm going to put here difference. And our a is going to be our 5x squared, the first term in the polynomial. And our b is going to be our second term in the polynomial y squared. Okay. And so what does difference pattern allow us to do? It says it is a squared, so 5x squared to the power of 2, minus 2 times a, which is 5x squared, times b, which is y squared, plus b squared, so y squared squared. All right, so let's go ahead and work this out. The squared is going to go to the 5, so it's going to be 25. And then the squared is going to go to the 2 as well, so it's going to be x to the 4. And then here we have a 2 times 5 times 1, so that's going to be a minus 10 x squared y squared. And then over here is going to be y to the 4, so plus y to the 4. So our final answer is going to be 25 x to the 4 minus 10 x squared y squared plus y to the 4. And we're done. Okay. Our last problem here is example 10 in the book. And example 10 looks like this. Let's see if I can put it up here. It's right here. A flying disc shaped like a circle has a radius of x plus 3 inches. Write an expression for the area of the flying disc. Secondly, we cut out a hole with a radius of x plus 1 from the center of the disc. Now write an expression for the donut that's left over. Right? So this is kind of an interesting problem that allows us to exercise the skills that we've just learned. So I'm just going to put some notes here. What the situation is we have a circle that has a radius of x plus 3 inches. Right? And then what we do is we want to find the area of this big circle. And then they're saying we cut a circle from the center of this circle that has a radius of x minus 1 inches. So it's x minus 1 inches. It's that small radius. And then we need to find how much area the donut has, right? Okay, so how do we solve this problem? Part A says find the area of the big circle. So then we know that area is equal to pi r squared. Pi times the radius of the circle squared. And we know what the radius is. The radius is equal to x plus 3. So radius is equal to x plus 3. So the area of the big circle is I'm going to put area of the big circle right there, a little b subscript. So then area of the big circle is going to be pi times x plus 3 squared. I'm substituting in the radius into my formula here. So now if you look here, we have a sum pattern, right? So we can go and evaluate this polynomial by applying the sum pattern. So that's going to become pi. And the first one is a squared, right? And so our a in this case is equal to x, and our b is equal to 3. So what is the sum pattern? It's a squared, so x squared, plus 2 times a times b. So 2 times 3x, right? Plus b squared, so that's going to be 3 squared is 9. All right, so we'll do a little bit of simplification, and we'll get pi times x squared plus 6x plus 9. We'll distribute out our pi next, and so what we're going to get for the area of the big circle is pi x squared plus 6 pi times x plus 9 pi. And so this is the area of the big circle. Now they're saying we're cutting out this area of the small circle, and how much area is left over, right? So for that problem, part B, what we need to do is find the area of the small circle. So area of the donut I want to say area of the donut, area D, is going to be equal to area of the big circle minus the area of the small circle. Okay, we know the area of the big circle. It's right here. We found it. Now, how do we find the area of the small circle? Well, the same way we found the area of the big circle, right? We know the radius of the small circle, so we can find its area. So let's go ahead and find that. We'll say a sub s is equal to pi r squared. And so that's going to equal to pi times 1 minus x squared. Now, if we look here, we can evaluate this polynomial to a power of 2 by applying this difference pattern, right? So let's go ahead and do that. We'll get pi times a squared. So this is a is equal to x, and b is equal to 1. Okay? So the sum of difference pattern says we do a squared, so it's going to be x squared minus 2 times a times b. So that's going to be times x. And then we're going to do a plus b squared. 1 squared is 1. So this is what we're left with, right? And then we'll distribute out our pi, and we'll get pi x squared minus 2 pi x plus pi. So we have the area of the small circle, we have the area of the big circle. Now we can substitute in to find the area of the donut. Right? So let's go ahead and say area of the donut is going to equal to area of the big circle, pi x squared plus 6 pi x plus 9 pi. And we're going to do a minus. So this first polynomial, we're going to minus our pi x squared minus 2 pi x plus pi. Right? And we can do this many ways, but I'm running out of room, so I'm just going to do it by subtracting the like terms, right? So these are two like terms. We have pi x squared minus pi x squared. That's going to be 0. We have 6 pi x minus a negative 2 pi x. So that's going to become plus, right? 6 pi x plus 2 pi x is going to become 8 pi x. Then we have 9 pi minus pi. That's going to become 8. So we're going to say plus 8 pi. So the area of the donut is 8 pi x plus 8 pi. The area of the entire circle is pi x squared plus 6 pi x plus 9 pi. So that's our answer. And I'm going to go ahead and put it up here. A is going to be pi x squared plus 6 pi x plus 9 pi. And then part B is going to be 8 pi x plus 8 pi.